Hello and welcome to Dr. T Math. I am T. In this video we're going to look at mean value theorem and Rawls theorem, which are sometimes confusing because they've got all sorts of jargon and notation and terminology and symbols that make it seem like something other than what it is, just basically slope. Finding the slope of stuff and finding parallel lines. So mean value theorem means that we've got some sort of f of x function, and we'll make it into a parabola in this case. Could be anything, could be a root, could be a rational function, could be a polynomial. We'll make a parabola in this case. And we'll say that f of x, in our case here, is 2x squared minus 4x minus 6. And in order to satisfy the MVT, mean value theorem, we need to have f of x being differentiable and continuous. It has to be continuous on the interval a to b, closed interval, and differentiable over the interval, open interval a to b. So for any polynomial, they're always continuous. They don't have any gaps, no holes, no removable discontinuities, like if we had x plus 4, x minus 7 divided by x minus 7, no holes, no removable discontinuities like so. They don't have any asymptotes or parts where the slope is undefined. There's no asymptotes like so, like we might get with 1 over x, or anytime x is in the denominator. And it's not a piecewise function, so we don't have to worry about like a jump discontinuity like so. And then also there aren't any corners. It might happen in a piecewise function, corner or cusp. And so it's a polynomial. This is a straightforward one. We know that it's continuous, meaning there are no spaces, there's no gaps. It continues through the domain interval. And it's differentiable over that interval. Differentiability is founded upon, or is assessed upon, whether it is continuous, A, and then that there are no cusps or corners there. And in this case it is. Okay, so it satisfies those two. And then for the third one, Rawls theorem is just a special case of mean value theorem where f of a equals f of b, but we haven't yet given the interval. So we're going to be over the closed interval from -1 to, we'll say, 5. -1 to 5, closed interval. And then here's where the notation comes in, where there's a number x equals c, where a is less than c, a is less than c is less than b, and then such that f primed of c is equal to f of b minus f of a divided by b minus a. Well, if I put two dots on our parabola here for -1 and 5, and that's approximately how it looks on the graph, -1 and 5, not exactly, but the one at 5 is going to be higher. Basically what it's saying here is that if we connect those, we'll call this one over here on the left A and this one B. If we connect those two dots, then we can make a line, and there is a slope to that line. And this right here is really just y2 minus y1 divided by x2 minus x1 in different notation. And then remember that, well, your derivative is actually the slope. And so what it's saying is there is some value c in between a and b, where the slope at c, the slope at point C, is equal to the slope at between a and b. So we can draw a parallel line, which makes sense because there must be a turning point, and that's a special case of Rawls theorem. There must be a turning point between these if there is any way to connect the curve with 2 points making a line. There's a slope, which means that it must turn in some way such that there is the possibility to make a parallel line using a tangent at one point on the curve between a and b. So it looks like more than what it really is. But you start off by looking at f. First you have to take f primed. Generally that's going to be, we'll use the power rule, 4x minus 4. And then we have to assess f of a, which is going to be -1, and f of b, which is going to be -2, it's going to be 5. F of 1 is going to be 2 times -1 squared minus 4 times -1 minus 6. 2 times negative 1 squared is 2 times 1 minus 4 times negative 1 is plus 4 minus 6 is going to give us 0. And then for f of 5, I think we're going to get a higher number. We're going to have, this is the original function, not the derivative, 2 times 5 squared minus 4 times 5 minus 6. 2 times 5 squared is 50, minus 4 times 5 is 20. 50 minus 20 is 30, minus 6 more is 24. So Rawls' theorem will not apply because these two are different. But really, what we're finding again is the average rate of change between those 2 points. And so what we've got is f of b is going to be 24, that's their y2, minus f of a is 0. And we're going to divide that by 5, that's our x2, minus negative 1, which is our x1. 24 over 6 gives us 4. 24 over 6 gives us 4. And then we're going to set our f primed equal to that and find the value of c. So if 4 is our f primed of c, then 4 is equal to 4x minus 4. Add the 4 over, you get 8 is equal to 4x, and x is equal to 2. Which means that at x equals 2, our slope, in other words, our f primed, should be equal to 4. So let's do f primed of 2. F primed of 2, just to check this, we're going to get 2 times 4 minus 4, which is 8 minus 4, which is 4, and those match up. Voila. So that's our mean value theorem. Now let's look at the special case of Rawls' theorem by just shifting our domain a little bit. Instead of from negative 1 to 5, we're going to shift our domain from negative 1 to 3. And long story short, we're going to end up having the same value of 0 at negative 4 and 3. Get rid of our stuff here. All right. So again, we're going to take this to 3 instead of 5. So we're going to have f primed of negative 1. We already know that's 0. And then we're going to have, f of 3, which will be 2 times 3 squared minus 4 times 3 minus 6, which is 2 times 9, or 18, minus 4 times 3. 18 minus 12 is going to get us to 6. 6 minus 6 is 0. And so then Rawls' theorem applies because f of a equals f of b. What this means then on our parabola is that we've got, well, we know from algebra 2 and probably algebra 1 that when we have our parabola that looks like, where's my crayon? There it is. Looks like that. There's our parabola. And we're crossing the x-axis here, so then our zeros are there, then we have A and B. And again, obviously there is a point, mean value theorem still applies, obviously there is a point in between these two where the slope is the same, the slope is going to be 0, and we call that the turning point or the vertex. All right, so this is going to be equal to 0. Again, the hard part to understand is this whole notation with f primed of c, and then f of b, and f of a, and b and a on the bottom. But really, this is just y2 minus y1 equals x2 minus x1. And so what we've got is 0 minus 0 is going to give us 0, and it doesn't matter what's on the bottom, but it'll be 3 minus negative 1, which is still 0. So our slope is 0, and we know that because when we substitute those values into the original function, we get 0 for the first one, we get 0 for the second one, so there's no vertical change. And then intuitively, we should be able to understand there is a turning point or a vertex or local minimum or maximum in between those 2 points. But let's just double, triple check for consistency's sake. And so 0 is going to be our derivative. We're going to set that equal to 4x minus 4. And solve for x, we get 4 is equal to 4x, and then x is equal to 1. That's where our vertex is. And going back to again, algebra 1, algebra 2, we could have just gone, if we knew that we were looking for the vertex, we could have said negative b over 2a, which is a shortcut that people learn in algebra 1, algebra 2, which is like a foreshadowing of the the first derivative here. So negative b is going to be equal to negative 4, which is 4, and then over 2a will give us 2 times 2, which is 4. And so that equals 1, which is our x value there. And we can substitute that into the original equation now, f of 1, and we're going to get 2 times 1 squared minus 4 times 1 minus 6, which will be 2 minus 4 is negative 2, minus 6 is negative 8. So our vertex, that point C now, C, is equal to 1, negative 8. And so mean value theorem is the general case. Special case is Rawls' theorem. And all this really is just the slope formula once again. So hopefully next time you see mean value theorem, you don't clench your teeth and pull your hair out, because that doesn't make any sense. It's really just x1, x2, y1, y2, and then finding the slope in between those. This has been Dr. T Math. Thank you.